Hello everyone, and welcome to today's discussion on the NextLabs Teamcenter Digital Rights Management product. It is designed to protect data in motion when it departs from the Teamcenter server. At NextLabs, we empower intelligent enterprises by providing industry-leading security solutions to protect business-critical data and applications. By employing a zero-trust data-centric security strategy, we go beyond mere perimeter defense. We provide robust protection for structured and unstructured data throughout its entire lifecycle, ensuring its safety no matter where it resides or is shared. In doing so, we enable organizations to harness the power of advanced technology, drive decisions through data-centric analytics, and foster secure collaboration. At the core of NextLabs' approach is our unified policy platform and dynamic authorization policy engine, areas in which we advance new innovations in data-centric security. This is achieved with the 80+ patents we hold, along with 30 pending patents in both the United States and Europe that are designed to automate least privilege access and safeguard information sharing. On the policy platform, business and security needs are digitized and stored as centrally managed attribute-based policies. During access attempts, the policy engine employs the attribute-based access control ABAC method in real time, evaluating and authorizing access based on user, device, resource, and contextual attributes. With our continuous innovation and deep industry and subject matter expertise, NextLabs has helped more than 200 Global 2000 companies and federal agencies implement zero-trust architectures and data-centric security solutions to address information risk, regulatory compliance, data governance, access management, and secure collaboration challenges. NextLabs collaborates with Siemens to provide an end-to-end solution to protect sensitive product lifecycle management (PLM) data throughout the Teamcenter ecosystem. Our digital rights management (DRM) solution provides out-of-the-box integration with Teamcenter to enhance secure information sharing within and outside of Teamcenter. Before we delve deeply into the product, let's first understand why NextLabs partnered with Teamcenter to co-develop this solution. We frequently witness the sensitive and critical data of organizations being leaked with ease. Primetime news often reports instances where organizations' confidential product designs are disclosed without their awareness. In some cases, individuals simply take screenshots of product designs from the NX application and release them. Such leaks deal significant blows to businesses as competitors can capitalize on their exposed designs. Government projects have stringent compliance processes. Therefore, every major organization working on confidential government projects must ensure that their designs are both secure and compliant. If security is breached and data is compromised, the organization may face substantial fines. In some extreme cases, the head of the organization could even face imprisonment. In certain stringent situations, organizations are required to prove their compliance, otherwise they need to pay hefty penalties. The paramount consideration is the extension of Teamcenter permissions to files when they are located on users' local machines outside of Teamcenter governance. An organization has meticulously established a set of access rules within the Teamcenter application to govern file accessibility and security. It is our objective to apply these stringent access controls uniformly, ensuring the same level of security and governance even when the files are utilized outside of the Teamcenter environment. When a file is shared with an external supplier for manufacturing, a field service agent for servicing, or during a collaboration with another organization, maintaining file security during the sharing process is of utmost importance. This is precisely where our product steps in, acting as a bulwark to safeguard the files in transit. It implements stringent protection measures including file expiration features. Moreover, shared users are only able to view the file through the TcDRM browser-based web application, a secure platform where edit controls are disabled, preventing unauthorized alterations to the files. Teamcenter PLM is typically deployed as a 4-tier architecture that would involve separating the system into 4 distinct components or tiers that interact with each other to form a complete solution. Here is a general breakdown of a 4-tier architecture in the context of Teamcenter. In the client tier, Teamcenter Rich Client is a desktop application providing a full set of features for end users. It's used for accessing and working with data managed in Teamcenter. Teamcenter Active Workspace Client is a modern web-based client that provides access to Teamcenter from a web browser, allowing for a more flexible and accessible user experience. CAD applications like NX or Creo can connect to the Teamcenter in managed mode to work on the CAD assemblies. Web tier. Web server is responsible for handling HTTP requests from the clients and facilitating the communication between the client tier and the application tier. It serves the Active Workspace client and other web-based interfaces. FMS Proxy facilitates the secure and efficient transfer of files between the client and the file management system (FMS) in Teamcenter. Client API is a set of tools and interfaces that allow for the integration and interaction with Teamcenter functionalities programmatically from client applications. Security in the web tier implements protocols and measures to protect data and services in the web tier from unauthorized access and cyber threats. Application tier. Teamcenter Server is the central hub that manages and processes business logic, workflows, and data transactions in the Teamcenter environment. Pool Manager coordinates the distribution of server requests to different servers in a pool, optimizing resource utilization and managing load balancing. File Management System (FMS) Server manages the storage, retrieval, and distribution of large files and documents within the Teamcenter system, ensuring efficient and secure file handling. The dispatcher is responsible for managing and distributing background tasks and processes in the Teamcenter environment, facilitating optimized and automated workflow execution. Data tier. The database server is where the data is stored. Teamcenter uses databases to store structured data like item details, bill of materials, and more. The volume server handles the storage of unstructured data such as documents, images, and other file types. This tier ensures the efficient storage and retrieval of large data sets. Communication between these tiers would typically be client tier to web tier to application tier, and data tier and response comes back through the tier in the same order. For our solution Teamcenter Digital Rights Management Data on Motion, the major components we need to take a look at are FMS Proxy, FMS Server, and volumes. Let's zoom into this process flow to understand more. The Teamcenter client initiates a request for a specific file. First, the system checks the FMS client cache to see if the requested file is already stored locally. If found, it is served directly from the cache, speeding up the retrieval process. If the file is not in the client cache, the request is forwarded to the FMS server, which then checks its own FMS server cache to determine if the file is stored there. If the file is not stored in the server cache, the FMS server retrieves the file from the appropriate location in the Teamcenter volumes, where all files and documents are stored permanently. Once retrieved, the file is sent to the client, and it may also be stored in the FMS server cache and FMS client cache for quicker access in future requests. This flow ensures an efficient file retrieval process, minimizing the time and resources needed to access files repeatedly. In a standard workflow, a user may request a specific file from the Teamcenter server. Initially, the file is unprotected at the volume server. The FMS server responds to this request by retrieving the file from the volume server and transmitting it to the client. While the secure channel safeguards the file during transit, it remains unprotected once it arrives at the client's end. This scenario can potentially expose the organization to several risks, including design and manufacturing vulnerabilities. We have outlined some of these risks along with suggestions to alleviate them. Risks involve accidental data leakage. Unprotected data on client terminals constitutes a significant risk, as users might inadvertently leak information to unauthorized third parties. Malicious attacks. Malicious entities may target client machines to steal unprotected data. Data corruption. Data might be maliciously corrupted during transit from one location to another. Legal and regulatory compliance issues. Ensuring adherence to legal and regulatory compliance is essential to protect sensitive files. Lack of manufacturing controls. A deficiency of controls over data during the manufacturing phase can pose significant risk. The TcDRM architecture encompasses three primary components that work synergistically to protect and manage data. Here is a more detailed breakdown of each component. TcDRM RMX component. This component ensures that files leaving the Teamcenter are encrypted by TcDRM, thereby securing the data. It utilizes the SkyDRM encryption library along with keys from SkyDRM to safeguard the files. SkyDRM server component. This component is in charge of creating access policies and distributing them to all clients, thereby granting users the right to open the protected files. It manages keys by generating new keys to protect files and issuing keys to decrypt and open protected files. It facilitates the federation of all internal and external users of the organization, enabling them to log into the SkyDRM ecosystem and work on the protected files. This component is responsible for evaluating file writes server-side and consolidating the audit logs of user access to the protected files from all clients. SkyDRM Client Component. The R&D client assists users in viewing files through an inbuilt viewer, provided the user has access rights. It enables users to manually classify and protect files. The client grants access to trusted applications, allowing users with the necessary permissions to open, view, and edit the files. The CAD RMX facilitates users in executing all CAD operations on applications such as NX, Creo, SolidWorks, AutoCAD, and more. Now, let's discuss the mitigation of data risk in the Siemens Teamcenter when users work on files locally on their machines, retrieved from the Teamcenter server using the TcDRM extension. With the integration of TcDRM in the environment, the Teamcenter RMX, a reverse proxy, is positioned at the forefront of the FMS server side to handle incoming file requests. This pivotal component communicates seamlessly with the SkyDRM server to acquire the necessary encryption keys, effectively encrypting files as they exit the Teamcenter, adding a robust layer of security. This is how the process unfolds. The Teamcenter client on the user's machine initiates a request, which is directed to the TcRMX reverse proxy. This proxy then forwards the request to the FMS server, facilitating the retrieval of the requested file from the volume server and then relaying it back to the reverse proxy. Following this, the reverse proxy interacts with the SkyDRM server to acquire the necessary encryption key. Concurrently, it gathers classification information regarding the business object from the Teamcenter server, using these to secure and protect the file. This fortified file is then transmitted back to the client. Now, on the client side, within their workspace, the file stands protected and secured by the stringent SkyDRM access policies. This vital intervention forestalls the design and manufacturing process risk we highlighted earlier, ensuring a secure and efficient workflow. The SkyDRM server's key management system is equipped with two distinctive features that bolster an organization's defenses against external attacks. Firstly, it employs a unique key for each individual resource. This strategy ensures that even if a single file were to be compromised, all other files within the organization retain their security. This pivotal feature serves as a powerful deterrent against unauthorized multi-file access, thus safeguarding sensitive data at all times. Secondly, NextLabs utilizes AES-256 quantum-resistant encryption to secure file contents. This advanced form of encryption not only guarantees the protection of data with a robust cryptographic shield, but also ensures adaptability by remaining aligned with the latest developments in cryptography. This continual alignment is crucial in maintaining a vigilant stance against potential external threats, ensuring your organization's data remains impervious to breaches. In harnessing these two robust features, we create a fortification that stands resilient against external threats, securing your organization's valuable resources and maintaining the integrity of your data management systems. Many organizations aim to extend their internal access rules, such as ADA licensing, to files when they are accessed outside of the Teamcenter. In such scenarios, we implement a dynamic authorization policy within the SkyDRM framework. A typical policy might resemble: grant view and edit access when user.ada licenses equal resource.license list. To facilitate this, our clients are required to retrieve user ADA licenses from Teamcenter, read the license list from the protected file, send an evaluation request to the NextLabs decision engine to obtain the user's permission list for that particular file. With these steps completed, the policy comes into effect, granting the relevant rights. The corresponding application then opens the files, with rights control being managed through RMX extensions. For external users who are not defined within Teamcenter's access controls, distinct policies are established in the TcDRM policy management system. When these users access the protected NXL files, relevant policies are activated and access rights are conferred to the respective application extensions to enforce the rights. The range of access rights we typically grant includes view, edit, save as, screen capture, print, extract, file expiry, watermarking. These rights ensure a comprehensive yet flexible approach to file security and access control, accommodating a range of user needs and organization protocols. When a user logs into the TcDRM client application, the corresponding attributes from the identity provider IDP are retrieved and stored in the local user cache. Here is a step-by-step breakdown of the process that occurs when a TcDRM client, like the NX application equipped with NX RMX, opens a protected file. User authentication. The user logs into the TcDRM client application where their IDP attributes are retrieved and stored in the local user cache. File access. In a TcDRM client, such as the NX application with NX RMX, the protected file is opened. Metadata retrieval. The TcDRM client reads the header information of the protected file to extract metadata, which is used to construct a resource object. User object creation. The TcDRM client accesses the user attributes from the local user cache and creates a user object, facilitating a secure and personalized user experience. Permission request. The TcDRM client formulates a request to check permissions, which is sent to its local policy decision point, PDP. Permission retrieval. The PDP processes the request and returns a list detailing the user's permissions pertaining to the resource in question. Permission enforcement. NX RMX receives the list of permissions and implements them within the application, thus ensuring that users can only access data and perform actions within their designated privileges. By adhering to this structured process, we maintain a secure and controlled environment, mitigating risk associated with unauthorized access or actions. Teamcenter DRM features are the following. Protect the files downloaded or checked out from Teamcenter application server. Policy-based filtering of files based on extension and business object metadata. Protect the files using TcDRM SDK. Transparent viewing and editing of protected files for authorized users in CAD applications. TcDRM desktop client authorized users based on ABAC policy. TcDRM CAD RMX enables users to work transparently with protected files. Deny access to unauthorized users accessing protected files. Unprotected files uploaded or checked into Teamcenter application server. Now, let's move into the demo where I will show the level of fine-grained data protection Teamcenter DRM offers to enterprises, enabling seamless and secure collaboration. We will be using a user named Jimmy Carter who has full access to assemblies and parts classified as secret, but no access to top-secret parts. In the first part, Jimmy Carter will view a confidential assembly, make edits, and check in the assembly. In the second section, a part in the assembly is reclassified as top secret, causing Jimmy to lose access to the file. This function is incredibly helpful in supplier collaboration, where supplier A should only see his or her part and how it fits to the assembly, while hiding parts entitled only to supplier B. Similarly, supplier B will only be entitled to see his or her parts and how these fit into the assembly, or while supplier A's parts are not visible to them. We will start by opening up the assembly. Let's check the file info. You will see that this file is classified as secret, allowing Jimmy full permissions. You will notice Jimmy also has permissions to the part Lianhe, which is the chain guard. This is currently classified as secret. However, later, we will duplicate the assembly and change the classification of Lianhe to top secret, where you will see Jimmy will no longer have access to the part. You will also notice that there is a watermark on the assembly file, which helps to identify the insider or credentials which got compromised to leak the picture of the file. Now, let's make some edits on the file and check in the file. You will see the user experience is quite seamless with Teamcenter DRM, causing no disruptions in the workflow. Let's check in the file now to the Teamcenter server. I will go ahead and close the file, so we can see if the changes propagated to the Teamcenter DRM server in its embedded viewer. As you remember, we removed a small circle from the part in our edit. You will see this is now reflected when we view the part in the embedded viewer. We'll go to Named References, and you can see the part Lianhe that is reflecting the edit. I will now close the window. The product file has now been duplicated, and the classification of the Lianhe part has been changed to top secret. Let's try to download the file and see what happens for Jimmy. I will go to the download folder, right-click on the file, select SkyDRM, and view file info. You will see I am denied access to the part file. Now, let's try to open the assembly. Once the assembly and parts are loaded, an error message is displayed stating the part I do not have access to. I will click OK, and you will see that Jimmy can see all other assembly parts except the chain guard, as it is top secret. As we conclude this presentation, please remember that for further queries or clarifications, you can reach out to NextLabs at any time. Thank you for your attention. If you enjoyed this video, please like, share, and subscribe to the NextLabs channel, and stay tuned for more data-centric security videos.